Hello everyone, my name is Muhammad Chandra Saputra. I'm from University of Miyazaki. I will present my research. The title is Code Coverage Similarity Measurement using Machine Learning for Test Case Minimization. This research supervised by Professor Tetsuro Katayama. This is my outline presentation. So this is the research background. Testing on software development is a process that consists of test case selection, test case classification, execution, and quality estimation. Evaluation of the test suite is required to measure the efficiency of testing by collecting the information the number of redundant test cases. The redundant test case on the test suite mean that the test suite contains several test cases related to the same test work or objective. IEEE has defined the definition of the test case as a set of test input, execution condition, and expected result developed for particular objective, such as to exercise particular program, had or verified compliance with specific requirement. And the test case minimization tries to discover the test case and then exclude the inefficient test cases from the original test suite. Similarity among the test case on the test suite is possible to exist on testing process. The similarity found by comparing the test case coverage information. The test case coverage information that using on this research is the result of the test case execute as line of code execute during the testing. The test cases are similar when the test cases have a similar line of code executed. And also, this research using machine learning algorithm to classifying the similarity problem. Measurement of test case similarity information is better to reduce the number of similar test cases in the test suite and increase efficiency in the testing phase. The classification algorithm attempt to predict the level of each test case similar. This research uses the supervised machine learning approach to classify the similar test case. Classification on the test case similarity is often highlight useful information for decision making to the next process to similar test case as redundant test cases. This is the research objective. This research interests to find the similarity of test cases based on the test case coverage information using support vector machine, k-nearest neighbor, and decision tree. After that, we comparing the result of probability on similarity from several machine learning algorithms. This research also interests to evaluate the performance of machine learning algorithm based on accuracy and error rate. This is the literature review. We using the principle of similarity and redundant test case such as follow. The principle of similarity is how much alike among the object. One criteria of good test case is they have a different purpose. In the case of test case partially overlap, we cannot drop either one without compromising the coverage. There are two basic similarity identification approach uses in machine learning, such as classification and grouping. And this research uses a classification approach to classify test cases similar to other in the test suite. A classification approach is a systematic approach to assigning the object to one of several categories. And also, classification is to predict the object label from unknown records. And the next, machine learning is generally using on the software testing. On this research, we try to identify to which of a given set of the class and new elements belong. The problem we want to solve with machine learning on this research is classifying the similarity of test case based on the code coverage information from the test case. Supervised machine learning, we using on this research with labeled training data, which means that the data training already identified with the correct answer and proposed to gather to the best as possible classified. The labeled training data help to make a good prediction model. And also, we evaluate the performance of classification based on the count of the record correctly and incorrectly predicted. On machine learning experiments, performance metrics are used to compare the trained model prediction with actual data. The evaluation is to enhance the accuracy of classification results. We using disease performance metric measurement for evaluating the methodology. This is the research experiment. This research uses evaluation of test suite by analyzing the test case similarity on the test suite as redundant test case to increase the software efficiency. The research used the support vector machine, k-nearest neighbor, and decision tree with the supervised machine learning algorithm. We using this algorithm on the case of white box testing. The similarity measurement among the test cases use a combination of several test cases from all test cases on the test suite. This is the step-by-step of the experiment. The first step is the test case will execute on Java source code, and then we collecting the information as line of code execute. After data we collecting, and then we label with similar and dissimilar. Similar if both of the test case execute similar line of code, and dissimilar if both of the test case execute different line of code. And the training data set divide into two subsets. The first for training and second for validating the model. The validating process prevents overfitting problem and makes trained model have good predictive abilities. The training process began using support vector machines, k-nearest neighbor, and decision tree. The result from training process is the prediction model. Evaluation we using on this research is to know how well the result from the support vector machine, k-nearest neighbor, and decision tree is using performance metric measurements such as accuracy and error rate. And evaluation metric use accuracy and error rate to explain the performance of a model. And metric are the only way to understand the machine learning method of doing a good job or not. The metric show how many predictions were made correctly or incorrectly. This is the data we using. This is the test case code coverage information. 1 is for executed and 0 for not executed. Test cases used in this experiment are based on the Java source code, and we have 10 test cases. The test case were then executed to the simple Java source code to collect the line of code executes as known as coverage, and then by using support vector machine, k-nearest neighbor, and decision tree to classify the test case based on the similarity among the test cases. The experiment also cloned the Java source code using code clone approach and then generating the test case. This is the number of data training for model, and the number of test case on the test suite for the model is 10 cases. Consider the simple Java source code, and then we investigate the 10 test cases by manual to count the unique number of test cases from the test suite. So the next presentation is result and discussion. On the result and discussion, the figures show the result from training and testing classification by several methods on machine learning. The dot with red color means similar, and yellow color means difference, and X result means misclassification. The number of misclassification for similarity and dissimilar we using to evaluate the performance of support vector machine, K nearest neighbor, and decision tree on classifying the test case dataset. The result from machine learning prediction model for similarity classification applying to the test classification threshold on each algorithm is indicated which test cases are similar and unique. This is the result of classification, result of number of similar test cases, and accuracy, also error rate. The threshold value consider completing the minimum number of test cases based on the manual investigation on the test case similarity. So we want to know the minimum number of test cases from each machine learning approach. The value of the threshold on support vector machine is 0.96 with 7 comparison test case similarity value classified. The value of the threshold on the KNN is 0.86 with 13 comparison test case similarity value classified. The value of the threshold on the decision tree is 0.83 with 14 similarity value classified. The manual investigation on similarity show that the support vector machine has access to test case, and KNN access 8 test case, and decision tree has access 9 test cases. The performance metric measurement result on table 2 show that accuracy for each machine learning algorithm. Support vector machine has the highest score on accuracy and the lowest score on error rate, and then KNN, and the last is decision tree. By using machine learning algorithm, similar test cases are classified, and then the test cases are minimized with considering product rate. The classification result need to verify to ensure are non-repetitive test case. The verification result is the support vector machine has no repetitive test case, KNN has 2 repetitive test case, and the decision tree has 4 repetitive test case. And support vector machine is the best approach for reducing number of test case compared to other approach. So the conclusion for these experiments, the research confirmed the number of redundant test cases on the test suite is reduced because the classifying the similarity using machine learning algorithm. The best classifier machine learning in this research is the support vector machine. Reducing the redundant test case on the test suite decrease time on testing and increase the test case quality. The current research minimize similar test case without considering path coverage from the test case. For the future research, is need for classification using machine learning algorithm to consider path coverage. And I think it is all my presentation. Thank you for watching. See you next time. Thank you very much.